All right, example number 1, we're going to go ahead and find the solutions by doing the quadratic formula. All right, so let's go ahead and let's get cracking here. Okay, so first thing, so here's the formula. It's good to have that written down. And notice that it's in this form. This is called standard form right here. And standard form means that it's the x squared, the bx, and the c term are all on the same side, and it's equal to 0. That's what standard form means. Okay, so like as you can see in this example, that it's in standard form. The x squared, the x, and the c term, they're all on the same side and it equals 0. So once we have that, we can go ahead and plug in what is our a, b, and c. The a is next to x squared, so that means 4 would be our a. So it goes a, b, so b would be negative 11. And then our c term is our constant term, negative 3. Okay, so what we're going to do now is we're going to replace the b and the b and the a and the c and the a all with these numbers right here. Okay, now the way that I like to set it up is I'm going to rewrite the quadratic formula. However, I'm going to put parentheses anywhere I see the a, b, or c. Okay, I think it really helps a lot when we plug in the numbers, and sometimes we have double negatives. It helps not to make errors with the signs. Okay, so I'll have x equals negative b plus or minus the square roots of b squared minus 4 times a times c, and that's all over 2 times a. All right, so notice I rewrote the quadratic formula, except I replaced all the variables, all the a, b's, and c's with parentheses. So now it should be kind of cool. Now I'm just gonna plop in where all the numbers go now. Okay, so this was b, so b was negative 11, and this is b right here again, so that's negative 11, and this is my a, so that's 4. This is my c, which is negative 3, and this is my a right here, which is 4. All right, so this is my b, b, a, c, and then my a. So all I do is I just replace those. Okay, so now it's just a matter of us simplifying this. All right. Let's go ahead and go to town on this. Well, a negative times a negative is a positive 11. Cool beans right there. Okay, and then we're going to go ahead and simplify what's inside of the radical. And we'll do this in 2 steps here. Let's first go ahead and square negative 11, which is 121. Okay, and now we're going to multiply negative 4 times 3. So let's see here. Let's just forget about the signs right now. Let's just multiply 4, 4, and 3. 4 and 4 is 16. Times 3 is 48. Okay, now the question is it plus or minus? Okay, well, a negative times a positive is a negative. So this right here is a negative right here. And then if this is a negative times a negative is a positive. Okay, so be careful there with those signs. And this is all over 8. Okay. Let's go next line down. So I'm going to keep my 11 there. That's nice. Now let's go ahead and simplify this guy right here. And we'll get square root of, what's that going to be? A nice number. Let's see, 169 all over 8. Okay, so then we'll come over here. So x equals 11 plus or minus. Now we can take the square root of 169. And that's one of our very nice perfect square numbers right there. So it's going to be 13 all over 8. Okay. Now here, this again is the notation that we use to represent both answers in one statement. But we probably want to write out what are the 2 separate answers. Okay. So let's see, what are the 2 separate answers here? Well, one of them is 11 plus 13 all over 8. And the other is going to be 11 minus 13 all over 8. Let me just scroll down there a little bit. Okay. Okay, so let's simplify this. So 11, let's see, 11, 13 gives us 24. Okay, and then we're going to divide that guy then by 8 and get 3. And 11 minus 13 is negative 2 all over 8. And let's see, if I want to simplify this, I could divide both the top and the bottom by 2. So I'm going to divide the top by 2 and divide the bottom by 2. So I get negative 1/4. So those are my two answers right there, 3 and negative 1/4. And we derived that by using the quadratic formula. And these represent the x-intercepts or the solutions of our quadratic.